Hi everyone, and welcome to Cloud Native London. Thank you for joining us. We're going to hang out for about 15 minutes and listen to a little bit of music together. So we're going to kick off at 7 p.m. UK time in about 15 minutes. In the meantime, feel free to go to this link, oishell.com/r, where we'll be hanging out and just chatting and listening to some music together. We'll be back in 15 minutes. We'll be kicking off in 1 minute. It's your 1 minute warning. Alrighty, welcome everybody to Cloud Native London. We are a strong, open, diverse developer community around the cloud native platform and technologies in London, but as of now, everywhere in the world. My name is Cheryl, I'm your host tonight. I'm also the VP of Ecosystem at the CNCF, which is the foundation that hosts Kubernetes, Prometheus, and lots of other open source projects. Tonight, we've got 3 speakers for you. Joel from Red Hat, who will be our first speaker. He's going to talk about eventually consistent testing for Kubernetes controllers. Then Stephane will talk to us about why you should take care of infrastructure drift. We will take a 15-minute break and then come back for our third speaker, Robert, who will talk to us about replicated block storage with LINSTOR. And then we're going to wrap up at 9 p.m. UK time. But enough about me. I want to know a little bit about you. So please grab your phone, laptop, tablet, whatever you want, and go to this link, oicheryl.com/p. And this will take you to a live polling service called Poll Everywhere, where you can enter your name and you can skip if you don't want to leave your name. But I'm going to ask you a couple of questions about you and then a couple of questions about how you use Cloud Native, just so we can all get to know each other a little bit. And if you lose this link, don't worry, there's a slightly longer link you can use in just a moment. All right, here we go. So is this your first time at Cloud Native London? Your choices are yes and no. So you should be able to just click on them and then we can watch the results as they come in. Cool. The no's are coming in strong this evening. So it's great that, great always to have new people as well, and great to see people coming back and enjoying these meetups. I'm going to give this sort of about 30 seconds because there's a little bit of a delay, and also just give people a chance to find out and figure out the Polling Everywhere service. Instead, if you lost that link before, you can use this slightly longer one. Cool, couple of answers still coming in. Give it another 5 seconds. Okay, awesome. Looks like we're about 70% returning and 30% new. So welcome, whether you're first time or not. Okay, next question. Where are you right now? As I said, usually we are based in London. This is Cloud Native London, but now we're virtual, so we can be everywhere. So tell me where you are right now on this map. You just put a little pin in where you are. I think I saw someone's in Scotland, quite a few people around the UK, France. A couple of people from France, nice. Oh, someone's in Australia. This is cool. Isn't this like a crazy time for you in Australia? But if it is, that's awesome. And we want to say thank you. Thank you for joining in the middle of the night. Cool, I'll give it another few seconds for people to add in there where they are. Okie dokie, seems like the answers have settled. So let us keep going. Last question about you. What is your job title? So just pick whatever is closest to what you're currently doing. Your choices are architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or anything else. And if you're anything else, maybe you want to introduce yourself. So if you're on YouTube, you can put into the YouTube chat where you are, what you do, or you can put it on Twitch as well. Just sort of get to know each other. SRE and DevOps engineers coming in strong here. I think this is, yeah, this is probably the strongest showing I've seen of SRE and DevOps engineers. Usually it's a mix between kind of architects and SREs. So this is cool. Very nice. And then now I have a couple of questions which were submitted by our speakers and how they want to get to know you. So I want to invite our 3 speakers this evening to just come on and just chat about the results as they come in. First question, have you ever had any experience with custom Kubernetes controllers? Your options are, I've written my own, I'm using some of the community custom controllers, not using any, but plan to, not using any at all. What is a controller, and what is Kubernetes? And Joel, I think this question was yours, right?
Yeah, it was. So obviously my talk is about custom Kubernetes controllers and how you test them. So if there's people here who've already done it, then maybe they can give me some feedback, which would be great. If there's people here who don't know what Kubernetes is, this talk really isn't going to be for you. I was hoping most people would have heard of Kubernetes and have a little bit of a background on it before I did the talk. Yeah, it looks like a good mix. We've got some people here who have, some people who are using them.
Yeah, I think a mix is good. I think if it seems like quite a few people are not using any at the moment. This is like 50%, right? Yeah.
Yeah.
So 50%, maybe you can sell them on the idea of why they should be using controllers.
Yeah, perhaps. I mean, there's all sorts of things you can do with a custom controller. Like literally the world is your oyster, but there's plenty out there. Like one of the most popular, I'd say, is probably Cert Manager. And if you haven't heard of Cert Manager and you're running Kubernetes, it's like a one-stop solution for TLS certificates. It's great.
Awesome. Okay, looks like the answers have settled a little bit. So let's go on to our second question. This question comes from Stephane. So, how many of you have ever had to face infrastructure drift issues, i.e. when there's an unwanted delta between the IAC codebase and the actual state of the infrastructure? So your choices are yes, sometimes, or never. I guess, Stephane, how would you rate like sometimes versus often?
Good question. Sometimes it's probably less often than oftentimes. So yeah.
Well, I'm curious, like what do you think, like is once a week a lot? Is once a month a lot? Like
yeah, that's a good question. Probably once every few days is often, and once every few weeks is sometimes.
And does this line up with what you expected, Stephane?
Yes, definitely.
Yeah. I'm interested to hear this because I didn't think it would be this high. But
yeah, that's why we created drift control, because this is high.
It is high. This is, yeah.
Yeah.
90-odd%. Cool. All right. Thank you, everybody. Let's go to our third question for the evening. Okay, so what kind of platform is most interesting to you? Your choices being a Linux-based hypervisor / virtualization platform, another kind of hypervisor, e.g. VMware, Kubernetes, or Docker. And Robert, what were you thinking here?
Oh, that's a good question. I mean, since we're at a cloud native meeting, obviously I was expecting mostly Kubernetes and Docker. But, you know, sometimes people just join because it's interesting, or they have multiple projects and they're actually more based somewhere else and doing something else. But yeah, I mean, the results seem to come in and it's pretty much what I expected.
Yeah, pretty strongly Kubernetes. Apart from that 11% who said they didn't know what Kubernetes was.
Yeah, that's the 12% on Docker and on Linux hypervisors now.
I'm very curious about that 12%.
At least we're consistent here.
Awesome. Thank you, everybody, for submitting your answers. That is the end of our live polling. I'm going to now say thank you for tonight's sponsors for keeping this running. Joe, you're doing your Red Hat shout out in your talk. Is that right? Okay, that's a yes. Humio couldn't send anyone this evening, but they asked me to tell you that Humio is a time series log management solution for unrestricted event analysis, scaling to multiple terabytes a day on-prem or hosted. Lizzie, would you like to say a few words for
Hi. Yes, hey everyone, I'm Lizzie from Technovo. Technovo is a challenger digital consultancy and we provide expert partnership and growth without creating dependencies or disrupting culture. So basically that means that we like to operate a little differently to other consultancies. We pride ourselves on investing in talented developers and working together to provide the best possible outcomes for our clients. We work across both the public and private sectors on some really interesting transformation projects. If you'd like to know more, follow us on LinkedIn or find me in the chat on Rambly. Really looking forward to hearing from the other speakers tonight. Thanks, Cheryl.
Sweet, thank you, Lizzie. Ashley, you are up.
Thanks, Cheryl. Hello, everyone. Palo Alto Networks, we sponsor Cloud Native London, not because we're a big nasty firewall company that just sell firewalls, but because we actually care about CNCF, not just because we use the software, but now we have a whole product suite that's involved in securing CNCF and cloud stuff in general. We are hiring. Please do look, jobs.paloaltonetworks.com. Other than that, have a fabulous event.
Thank you. Thank you, Ashley. And then lastly, Zan for Circle CI, and you have an extra slide. So over to you.
Awesome. Hi there. I would like to welcome you on behalf of Circle CI and tell you how excited we are to be supporting Cloud Native London. My name is Zan Markin. I'm a developer advocate at Circle CI. And have you ever thought about how your software delivery setup compares to other teams, how robust your pipelines are? Are you shipping more or less than your peers around the world? We at Circle CI have that data because we are the leading CI/CD platform out there. And if you'd like to know more about it as well, I'd like to point you to our State of Software Delivery 2020 report. The link is on your screen now. We released it a couple of months ago. We looked at 44,000 organizations and 160,000 projects, how they have performed in over 11 million workflows that we analyzed at various stages of 2020. Go to the URL, check it out. I'll also drop a clickable link on Rambly. And yeah, in any case, hope you enjoy tonight's meetup and I'll see you around.
Thank you so much, Zan. And thank you to all of our sponsors, without whom we could not keep this meetup going. If you want to come and speak or to sponsor, please go to cloudnativelund.com. Speaking slots are now booked up till October or November this year. So please plan ahead. If you're a first-time speaker, you're really welcome. Please come and share what you know. You can also sponsor events or you can promote your own events. And that is it from me. So I'm now going to hand over to our first speaker of the evening, Joel.
Hi, everyone. Let me just share my screen. Okay, so hopefully you can see my slide deck now. Yep, Cheryl's confirming. Brilliant. Okay, thanks, Cheryl. Hello, everyone. Today, I'm going to be talking about testing Kubernetes controllers. Building custom Kubernetes controllers has become more and more popular over the last few years, with projects like Kubebuilder and Operator SDK making it really easy to build custom logic for your Kubernetes cluster. The one thing I found hard when I started writing controllers was testing them. There was, and I think still is, very little documentation or guidance on writing tests for controllers. And so, I want to talk about that today. Before we get too far into that though, I'm Joel. I'm the team lead for the OpenShift cluster infrastructure team at Red Hat. Red Hat obviously are a sponsor today. Very happy to be sponsoring. The Red Hat, if you're not familiar, are makers of OpenShift, which is a distribution of Kubernetes, as well as a bunch of other open source tools like Key and Claire, Kubert, Podman, and loads of different things. I've been told to say that we're hiring engineers at the moment, so we're looking to develop our next generation of cloud native technology, and we are very, very remote friendly. I don't know if you saw, but on the map earlier, there were some people in the Czech Republic. Most of my team are out there, and I think some of them are watching, so that may have been them. If you want to know more about jobs at Red Hat, then I'll be around to chat afterwards. And I think it's jobs.redhat.com. Don't quote me on that though. Anyway, back to the talk. So the team I work on actually works on a project called Machine API within OpenShift. We also contribute to the upstream cluster API project. I'm going to briefly mention those, but I'm not really talking about those today. If you aren't familiar with these projects, they're basically solutions that allow you to manage your cluster's compute resources, or VMs, in a Kubernetes native way. So a machine maps to a VM, and then we have a thing called a machine set, which is like a collection of these that all look the same. So kind of like a pod, and then a replica set is a collection of pods. If you want to talk about machines or machine sets or learn more about that, again, I'll be in Rambly in a bit, so come and talk to me about that. If you have any questions after the talk, then my contact details are on this slide, so feel free to get in touch, and I'll make sure to share the slide deck as well. Finally, I've been at Red Hat for just over a year now, and before that, I was working for a company called Pusher, where I got heavily involved in building controllers. So most of the lessons I've learned from this are actually from the work I was doing at Pusher. So what we're going to talk about today. I'll start with some background. So at a high level, I'll talk about what a Kubernetes controller is, and then explain using that why they are hard to test. I'll introduce you to a tool called envtest and show you how to write some tests using it. And then I'm going to share some tips and tricks, which are various things that I've learned along the way as I've been writing my own tests. Finally, I'll do a quick recap and share all the links you need for all the things I'm going to talk about today. So, what is a Kubernetes controller? Well, at a high level, a Kubernetes controller is designed to reconcile differences between the desired state and actual state of some object. Kubernetes is a declarative system, meaning that a user defines their intended state is some resource. What is intended state? Well, that's just the configuration. For example, when you write a deployment in YAML and send that to the Kubernetes API, you have told Kubernetes the config that you want. That is the desired state. Kubernetes and the components within it are responsible for making that state a reality. It does this by looking at your desired config on the resource, looking at the current state of the world, and working out the changes it needs to make, and then actioning those changes. If we take a look a bit deeper, how does this actually work in reality? Well, as a user, you only interact with the Kubernetes API. You send it some data containing the desired state of your resource. And for example, this could be creating or updating a deployment. The API server will then accept your change and tell you the resource has been updated. If you do know Kubernetes, you'll know that that's not the whole story though. Under the hood, there's this thing called a controller watching the resource. Watching is a term in Kubernetes that means it has subscribed to changes for a particular resource. This is similar to PubSub if you've ever used PubSub before. When there is a change to the resource, the controller is notified of that change and puts the change event onto a queue. In the background, there is a process called reconciliation happening. Part of the controller is watching the event queue, reading events from it, and reconciling the state of the resources that triggered those events. It normally will handle these one by one, and in certain cases may take some time to reconcile these objects. If it considers the reconcile to be successful, it removes it from the queue, and if it fails, it will re-queue it. So why is that hard to test? The primary reason the controllers are hard to test is that they are eventually consistent. And what does that mean? It means that when the user makes a request to change the system, they update the config, it will take some time for that requested change to manifest into a real world change. So when you're implementing tests for your controllers, you'll want to ensure that your controller reacts to the events triggered by the user events, the user actions, and ensure that it reacts to those correctly. Now, clever organization of your code can allow you to test parts of this logic without waiting and relying on the API, but you'll probably want to test these in some way. And that's going to introduce complexity to the testing, as you now need to implement polling loops to wait for that reconciliation to happen, and timeouts in case there are any bugs in your code that mean it doesn't work properly. The second issue I see with testing controllers is that if you did want to write a fake for the Kubernetes API for unit testing, The Kubernetes API is so complex, it's nearly impossible to write a fake that will implement the behavior exactly as a real API would. As an example of this, what happens when you delete an object in Kubernetes? Well, you may think it just removes the object, but in fact, in some cases, it just marks the object by setting a deletion timestamp. The API server has like complex logic that will handle deletion in certain cases. And there's also a garbage collector that runs in the background and performs part of the deletion routine as well. This logic would be nearly impossible to accurately fake without just re-implementing Kubernetes. So to solve these issues, I want to introduce you to a tool known as envtest. envtest is a tool that was created to aid developers who are writing custom Kubernetes controllers. It is part of the Controller-Runtime project, which in itself is a library for running custom Kubernetes controllers. Controller-Runtime is actually the project at the heart of both Kubebuilder, the Kubernetes community framework for building custom controllers, and Operator SDK, the Red Hat framework for building custom controllers. You may be familiar with Controller-Runtime if you've used either of these projects. envtest essentially is a utility to allow you to run a real Kubernetes API as part of your test suite. It is designed to make it easy to test controllers without having to worry about setting up fake clients or mocking behavior. It allows you to use a real client. And when testing your controller, it should behave exactly the way it would if it were running in a real cluster. It has a number of configuration options that you can use, including automatically setting up custom resources and any webhooks that are required for your tests. I want to highlight some of the good parts about envtest as well as some of the bad parts. For the bad parts, however, I will hopefully discuss solutions to these later in the talk. Starting with the good, envtest is easy to get started, and its main advantage is you don't have to use fake clients. Instead, you get a real API, so the API calls behave exactly as they would in a real cluster. Since envtest uses external etcd and kubeAPI server binaries under the hood, it's also really easy to swap out the API version if you want to do some cross-version testing, for example. Thirdly, unlike testing in a real cluster, there are no other controllers running, just your controller. This makes it very easy to check exactly what your controller does in isolation and check that it matches your expectations. This isn't, however, a substitute for full integration testing. You should also be testing against real Kubernetes clusters to check what other weird interactions might happen between your controller and the built-in Kubernetes controllers. On to the bad. So starting etcd in the API server is going to take a little bit of time. Depending on the machine, this could be anywhere up to 5 or 10 seconds. Obviously, if you do this per test case, that is going to add up to a lot of overhead and make your tests unfeasible to run as like local unit tests. Secondly, envtest requires you to have pre-installed etcd and kubeAPI server binaries. So this adds some overhead for new engineers who are joining your team when they are setting up their development environment. However, scripts are available to help here. Thirdly, no controllers running means you also have no garbage collector. And that's fine if you start and stop the API for each test. But if you want to reuse the environment for multiple test cases, this means you manually have to clean up after each test. Finally, typically you'll register your controller and expect it to react to events as it would in a real cluster. You have no control over when it reacts to these events, so you'll have to make your test account for this. Looking into some alternatives. The primary alternative to using envtest is to use a fake client. While fake clients are faster, there are drawbacks. For example, some features just don't work correctly in fake clients. Things such as finalizers and sub-resources are a couple of the important ones that I'm aware of. Finalizers, if you're not familiar, are used to introduce custom deletion logic for your custom resource. So for example, if you're trying to delete an external object, such as you've created something on AWS using your custom resource, you would want to have a finalizer to allow you to clean that up when your Kubernetes custom resource is deleted. When using a fake client without finalizer support, you won't be able to test this deletion logic. There are some cases, however, where the fake client is useful. For example, the fake client allows you to inject errors and test how your controller reacts to API problems. So I'm not saying completely forgo fakes, but you can in a lot of scenarios. Another alternative is a project called Kind. And if you're not familiar with Kind, it stands for Kubernetes in Docker. So it's a tool that runs a Kubernetes cluster within Docker containers on your system. While this could be useful for testing, it takes a few minutes to spin up a fresh Kind cluster. So it's not ideal to start Kind as part of your test suite. That said, if you have Kind or any Kubernetes cluster running, envtest has an option to allow you to use this existing cluster for your tests instead of spinning up a standalone API. So you could use a Kind cluster for your test suite, sharing the cluster between multiple test runs. One thing to note though is that because Kind runs a full control plane, you may see your controller actions affect other parts of the system, which in turn may affect your test suite. So using Kind for tests would be much more similar to an integration test, and there are extra considerations you have to make in this case. So let's look at how we might write some tests for some controllers. To get started with envtest is relatively simple. You declare an environment, shown here on line 3, by telling it which custom resource definitions you want to install, and then you call start. The config variable on line 14, returned by start, is a fully authenticated client Go REST config that will tell a client how to talk to that newly started API. This means you can use it to initialize either a regular Kubernetes client or the Controller-Runtime client. There's also this add to scheme part on line 9, which is something you'll need to do during startup as well. This registers your custom resource definition so that the client understands how to encode and decode your custom resources. Without this, you'll see errors saying something like no match for kind in scheme. And so you want to remember this bit. One of the problems mentioned earlier was around the fact that it can take time to set up and tear down the test environment. Go has a built-in testing option called test main that allows you to do some setup and tear down actions before and after your tests are run. Using this concept, we can set up the latest test environment once at the beginning of the test suite, and then run all of the tests using mrun on line 9, and then do any cleanup after the test suite is run, such as stopping the environment on line 11. Unfortunately, there is very little way to share configuration for the clients into the tests when you use this approach. So you have to use a global variable for this, which is why it's shown on line 1. Now, this works well for setting up the entire test suite prerequisites, but then you have to make sure you're properly cleaning up resources on each test, as I mentioned earlier. This is where a project called Ginkgo might come in handy. Ginkgo is a behavioral-driven development, BDD, testing framework that has a number of advantages when it comes to writing tests for controllers. This slide shows exactly the same setup as the previous slide, but in this case, we are using Ginkgo. You can see on lines 10 and 15 before and after suite blocks that allow us to do the same setup and teardown as in the previous slide. I'm also using a package called Gomega in this example. Gomega is used to make assertions about the state of variables. You can see on line 13, I'm using a line expect error to not have occurred, which checks in this case that no error occurred on the previous line. Gomega is particularly useful when testing controllers and can also be used without Ginkgo if you prefer. I'll come back to that later. Before I go on too far, just as an aside, I wanted to highlight that when you're writing controllers, with controller runtime or without, there are two ways that you can interact with the Kubernetes API. There's the classic client Go controller clients, or controller runtime have actually introduced their own client that they hoped would be simpler for controller authors to use by abstracting away a lot of the typing information and making a very generic client. On this slide, you can see a comparison with a regular Kubernetes client on the left. To create and update the pod, I have to specify the specific typed client. In controller runtime, on the other hand, the client is generic and infers all of this typing information from the object I pass it. I could have put a deployment into the controller runtime client and it would work just as well. But for the client Go client, I have to change to the deployment client and then give it deployment. I personally prefer the controller runtime client and I find it much easier to use. I'm going to continue using it throughout this talk in code examples, so hopefully it's easy to understand. When writing tests in Ginkgo, you write them inside anonymous variables called describe or context blocks. Within each of these blocks, you can add before and after each blocks, as shown here on lines 4 and 10. These run before each test assertion and after each test assertion. In this example, we show setting up a new client at the beginning of each test, and then after each test, deleting all of the deployment and daemon set resources that were created by the tests. The delete all of method from the controller runtime client is really useful for cleaning up resources. You pass it an object of a particular type, and it will get rid of all of the ones of those of that type on the API. So you can really easily make a list of all the different object kinds used in your test and ensure that between each test, these resources are cleaned up. That leaves an effectively new environment for the next test. With this, you now have the ability to start writing tests that have access to a real API and ensure that any resources created by the tests are automatically cleaned up at the end, whether or not it passes or fails. The final thing to do when setting up your test suite is to create a manager, like on line 2, register your controller, that's line 6 to 8, and then start the manager on line 13. Importantly, when you start the manager, you must do this in a Go routine, as it is a blocking call. When calling Gomega expectations in a Go routine, you have to use this special defer Ginkgo recover call as well. This will catch any failures that may occur in the Go routine and prevent the whole test suite from panicking. Once you've run your tests, the after each block on line 17 calls the cancellation of the context, which shuts down the manager gracefully. There is some overhead in starting and stopping the manager and controller for each test. However, if you don't do this and you share the controller between tests, you risk having events cross over from previous tests, and this may cause your controller to start spitting out errors. This will make identifying any issues that occur harder than it needs to be. It's much safer to stop and get a new manager for each test. Once you've set this up, it's now time that you can start actually writing tests. Your controller is connected to the API and watching for events from the resources you're going to create. So onto writing a test. In Ginkgo, each test case is written inside an it block, like the one on line 4 here. One of the key benefits of using Gomega in testing is its asynchronous test assertions. In this example, I'm creating a custom resource on line 6 and then using an eventually asynchronous assertion on lines 9 through 15. This fetches the resource and returns its status. On line 15 itself, the assertion finishes with should equal. So inside that equal bit, we put an example of what the status of the resource should look like after it has been reconciled by the controller. If the controller is working correctly, it should react to the event when we create the resource. It should update the resource and its status. The eventually assertion will poll until there are no errors, and the status matches what we have specified in the equal matcher. In this case, that means that it will wait until the status is correct. If the condition isn't met within the timeout, then the matcher will print out an error at the end of the test suite showing the status of the object as it observed it and the status it was expecting, allowing you to do a diff and work out what was wrong with your controller. These asynchronous assertions are really powerful and allow you to easily write tests for your eventually consistent controllers without having to worry about your own loops and waiting on these conditions. Combine this with the structure of Ginkgo tests, the before and after setup, you can write really concise tests to test what is really some quite complex behavior. So that concludes the basic of writing tests for controllers. And now I'm going to go on to some tips, tricks, and gotchas about how to write tests and a bunch of things that I've learned over the last few years. So the first thing I want to mention is the Ginkgo CLI. So Ginkgo is more than just a package for running tests. It also has this really powerful CLI that will run the tests for you. It effectively extends the Go test command and makes it more powerful. One of my favorite features is the parallelism options. By default, when you run tests with Ginkgo or otherwise, they are run all in serial. But to speed that up, you can use the nodes flag. Ginkgo will divide the test spec, that's each of the it blocks, between each of the test nodes and run them concurrently. What is also useful here is that each of these test nodes effectively works as a separate suite. So each node runs the before and after suite command in its own thread. This means that rather than your test sharing that one test environment, you'll get one test environment per test node, keeping the tests isolated from each other. Secondly, the CLI has an option to randomize the test ordering. So that is, before each run, it mixes up all of the orders of your it blocks and runs them in a different order each time. This is useful for finding dependencies between tests. Perhaps one of the tests has only passed because it relies on some previous state from a different test that didn't get cleaned up correctly. I'd encourage you to use this CLI and option in particular in your CI jobs, as it can be really useful for identifying flaky tests and dependencies between different tests. If you do find a test that fails randomly, the randomized spec option does also print the randomization seed, so you can rerun with the exact same ordering if you needed to. Finally, if you find you have problematic tests, you can also use focus and skip flags to pass a regex to either run only some tests matched by the regex or skip those that are matched by the regex. You can also do this programmatically if you prefer by prefixing each of the Ginkgo blocks with either a P for pending or an F for focus. So for example, a P describe won't run any tests, and an FIT will run only that test. The next thing, if you find you're having problems with cleaning up resources, an alternative you can try is to use a fresh namespace for each test, though this only works really if you have namespace resources being controlled by your controller. To do this, you can use the generate name field in the metadata object of a namespace object, as shown on line 7 here. When you create this, the API server will create a unique name for this namespace, and that allows you to create resources in the namespace just for that one test. If you use this namespace as an argument in the manager options, as shown on line 14, this restricts the manager to only be able to interact with that namespace, preventing resources from other namespaces or tests interfering with the current test. This one is something I want to show you, but recommend you don't do. It was previously recommended back in the days of Kubebuilder v1 that you could wrap your reconciler in a test reconciler, which would then put all requests onto a channel. This allowed you to watch the requests as they happened and wait until your controller had finished reconciling by waiting to read from that channel. This can lead to tests becoming blocked and lead to prematurely checking for results if some error occurred and your controller would have actually fixed it later. If you see this pattern lying around, it's probably from an early Kubebuilder project, and I'd recommend not copying it. It's much better to use the asynchronous assertions in Gomega that I showed earlier and wait for the result of what you expect your controller to be doing rather than wait for it to have reconciled explicitly. Remember, if there's any errors, your controller will retry, but this pattern doesn't cater for that. If you aren't a fan of the BDD style of Ginkgo, I wanted to let you know that you can also use Gomega without Ginkgo and use it with regular testing library as well. This means you can still leverage those asynchronous assertions and in any Go test you write. All you need to do is initialize a Gomega as shown on line 4 and call assertions on it later in the tests. This one is actually really important when you're writing controllers as well as writing tests. Kubernetes has a concept known as sub-resources. So these are parts of the object that can only be modified if you access a subpath of the resource on the API server. So for example, if you see a status inside a YAML object, that is a sub-resource typically. For example, on the API, if you normally get the resource from API/foo to edit the status sub-resource, you'd have to post the data to API. This is really important when writing controllers because status sub-resources are very, very common. And if you try to update the status using the regular client, it will have no effect. You have to use a status client as shown here on line 9. It's also really important to make sure that your tests account for any changes your controller may make. For example, if you get a resource from the API server, try to modify it and then return it to the Kubernetes API to update it, if anyone has made a change to that resource in the meantime, it will return a 409 conflict error. To avoid this breaking your tests, you can make your update calls in your test suites resilient by using this modify function concept as shown on this slide. Instead of getting the object, modifying and updating it, which may fail, we do the get and update within eventually assertion so that we can retry the update if there's a failure. The actual changes to be made are captured in the modify function on lines 3 to 5. And separating this code like this allows you to retry the update easily, and you could even make a helper out of this eventually block. Speaking of helpers, while at Pusher, myself and a colleague Matthias worked on a number of helpers to make our test suites easier to read and write. I'm currently in the process of trying to add this set of helpers to the Controller-Runtime project. The idea being that the example of the update we saw in the previous slide is wrapped into lines 4 and 5 here. There's this env variable which represents the matcher utility. We can add a timeout and then call any one of a number of asynchronous helpers, such as the update one shown here. This uses that modify function concept to get the object and attempt the update exactly as on the previous slide, but now we have a utility for it to make it easy to be reused between different tests. Below this, on line 7, there's also a custom eventually matcher. This takes any object, deployment, pod, it could be anything, and gets the object until the condition is met. This combined with the with filled helper allows you to extract different parts of the resource and make assertions against them. So in this example, we can use one assertion to check that status.foo and status.bar fields both match some condition. This assertion will only succeed if both conditions are met. I only actually got around to posting this helper utility last week, so I'm looking for feedback on the design at the moment. If anyone has time and some experience with tests, it'd be great if you could try it out and leave some feedback. And that's pretty much all I have for today. So to wrap up, because Kubernetes is an eventually consistent system, controllers may take some time to react to events and act on changes requested. To be able to test this, we need to make sure that our test suites are able to wait for the results. To do this, we can use envtest to write a test suite that doesn't rely on fakes. We can use Ginkgo to allow us to set up and tear down resources before and after each test. And we can use Gomega to write asynchronous assertions that will help wait for your controller logic to react to the events sent by the API. Thank you for listening, and I guess I'll take some questions.
Thank you so much, Joel. Yeah, that was fantastic. We are pretty much out of time, I'm afraid. So I want to move on and let Stephane have a talk, but what's the best way for people to get in touch with you if they have questions?
They can tweet me. My email's on the slide deck. I'll try and see if there's a way I can share the slide deck, and then people can message me from the contact details on there.
Okay, great. Thank you so much, Joel. Really appreciate it. Now I'm going to welcome Stephane to take over.
Hello. Hi there.
Hello.
So let me share the slides. Okay. So hi everyone. Thank you for attending this talk about infrastructure drift, and thanks Cheryl for having us tonight. Basically, I'm Stephane. I'm pretty much as Jourdan everywhere on the internet. I've been in this job for the past 20 years. I co-founded a bunch of companies here and there in Canada and Europe. And more recently, I created with a wonderful team, driftctl at CloudSkiff, which is solving problems that we're going to talk about tonight. I also happen to have written this book years ago. So the agenda, I'm pretty much having issues with the Zoom window. Sorry, I'm putting it here. So basically the agenda. So it's pretty straightforward. 3 major parts. The first will be about infrastructure as code, all the good intentions, the ideal world we all entered in when we started, and how it's actually going. It's probably quite different. I think the poll a few minutes ago showed that the ideal world wasn't exactly what people experienced. And then we're going to demo it, drift together using Terraform and AWS. And we're going to talk about how things went terribly wrong, terrible stories from the trenches. And at the very end of the talk, I'm going to show our own open source solution to solve all those drifting problems with a tool called driftctl, driftctl. So, and yeah, at the end, I will be on Reliably, obviously, as it's the new tool for meetups now. So let's go. So what is it about infrastructure drift? Quick definition for everyone else that may not be aware. That's what happens when reality and the expectation don't match. Also known as, oh my God, when things go wrong and we're not expected to. So how it started, the vision of truth, justice, and the ideal society, you know, Plato's Republic. So basically, infrastructure as code would allow us, would offer us a single source of truth. We would have versioning for our code. The code would be so great that it would be documentation in itself, and we would have testing, you know, BDD, TDD, and unit testing, and an acceptance test for infrastructure. It would be so great. Collaboration would be a bliss, and immutable infrastructure would solve most of our issues. And GitOps will solve all the problems with CI/CD for infrastructure, and things were not about to run locally anymore on our laptops, and then credentials would be under control. So as well, multi-cloud would solve many locally issues on different clouds, and the skills to manage all those APIs would be no issue, no problem on the teams, and time would be everywhere for everyone to learn all those new skills. So basically, that's how things were, we're going. So in our ideal world, but this bright future probably is not exactly what you experienced. So what happened exactly inside the team? Many of us were quite experienced with production systems, automation, you know, Terraform, different clouds, Azure, AWS, etc. And we had experienced a lot of things, and we narrowed down some issues, and we wondered, what if we were asking a lot of other people, DevOps, CTOs, etc., if they experienced this as well? So we did it. And we released recently a small study. It's a PDF on the website. You can get it if you want. And basically, what it told us was that the changes were still happening outside of Terraform. So for many good reasons, like lambdas running, changing tags, etc. A lot of scripts for maintenance, etc. And even manual changes. So in this ideal world where things were not to be changed manually because it was all fully automated, well, basically we discovered that it was confirmed that change were happening in this area, but also that a lot of other problems were happening, like sometimes all the commits were not exactly representing the full scope of change, like the processes were like heavily broken. We had people telling us that they were their process was sometimes to create manually the changes on the web console from AWS, and then manually backporting the manual change in Terraform. And yeah, and basically, they were creating step by step the thing that was created automatically by AWS, which is the wrong way to do it. But basically, that was they were doing this, and AWS creates a lot of things underneath when you create things manually, and yeah, it was not representing the full reality. All the testing stuff was great, but no time. It's hard, even if things like TerraTest are great. Very often the teams did not have the time and the skills to do them. During this, in bigger companies, teams, when you have many teams, communication is still an issue, especially in those COVID-19 times. Asynchronous communication is still difficult. And one thing we learn as well is people were still running, relying heavily on Terraform their laptops. CI/CD setups were sometimes so old. People told us that their setups were so old that they were not even able to run Docker on them. So to have a full GitOps setup running Go, binaries, etc., was like not imaginable in that case. So we had a lot of feedback as well about all the new stuff around immutable infrastructure. It's cool, it's working, it's great, but well, legacy systems in production are still running this year. So a lot of people had also still full access to the consoles for many reasons, because they are the boss, because they are the customer, because they are some special coworker. So yeah, in the proper GitOps way of doing things, it doesn't happen. But the reality of many people, it's still not the case. And guess what? Those guys do some changes. So while we learn as well that a source of problems in managing different clouds and even automation is that even if you are highly skilled at one cloud provider, it's not necessarily the case with many cloud providers. All have their own specifics, and it's not obvious that you have the time to scale up on all of them. And even if you do, we had people telling us that they had many issues with, say, GitHub, like anything that has an API that can be automated. It's maybe not yet under Terraform, that kind of thing. So if you have hundreds of thousands of repositories to manage, a single change, manual change, can have a huge impact that you do not see. So basically, all this behavior have something in common. They generate drift, and they lead to drift. So it's maybe cool for cars. There is cars on the slide, and the discrepancy between intention and reality can in fact lead to major issues like security issues, disaster from misconfiguration. Well, it's sometimes oftentimes, like the poll asked at the beginning of this session, it can be huge. So I talked a lot about Terraform at the beginning of this talk. Let's get the record straight. Terraform is a wonderful tool. It's an excellent provisioner, but obviously it's not a tool meant to manage what's outside its scope. What I mean by that is that if you create something manually outside your code, don't expect it to see it. And sometimes because of the way APIs are done on AWS side, a change for something that was managed by Terraform is reported as a new resource, as something that is outside of the Terraform scope. So very often, for those of you who know Terraform, you can still put Terraform plan and apply in CI/CD or in cron tabs and end up with apply complete, resources 0, added 0, change 0, destroyed. And while major changes happen, that's what we're going to show in a couple of minutes. So to work around that, a lot of other tools exist. There are security and compliance tools. I think I showed some a few months ago at this very same meetup. But there are very different tools and definitely not related to automation and provisioning like Terraform is. So now about the stories and the quick demos. So basically, we had people telling us terrible stories about how things drifted terribly for them. And in this case, so I simplified them a lot and anonymized them as well. But we had people telling us that one day this intern had a problem accessing AWS. So he had this very simple Terraform profiles, etc. So the things were done quite correctly, but they made some manual change to help him. So, but it stood there for weeks without anyone noticing. And do you know why? I'm gonna share my screen, my terminal, sorry. So I hope you see things correctly. So here, very simply, that's the code. It's a dumbed down. It's the very simple version of the code, but basically it's an IAM user with some random string in it, an access key, which is a key to access the API that is linked to this specific user. And we have an attachment, the policy attachment, and that policy is clearly read-only. So that's what we have. Now let me share my AWS console, and we're gonna do what those guys did, thinking that they will remember it the next day. And so they said, okay, maybe the key is bad. So they deactivated the key, created a new one. They gave the secret to the intern. And basically 1 hour later, the intern came back and said, oh, it's still not working. I don't know why, etc. It was Friday evening. They didn't care and said, okay, we're going to add more permission and we're going to remember it Monday. And on Monday, we're going to roll it back. And anyway, it's on Terraform, you know. So our CI system will tell us that something changed badly, and we will remember it. So guess what? Let's go back to my terminal. If you Terraform apply on this setup, we have our keys, we have our policies, and we have our user. And unfortunately, apply complete. Nothing is added, nothing is changed, nothing is destroyed, which means that from now on, you have your intern running around with a rogue key set running with administrative access on IAM. So it's a very simple example, but that's one of the many dozens of terrible examples that we had. So let me go back to the slides. Oh, okay. So that's one example. Another example, terrible example, is quite similar in the situation. It was late. People needed to work from home. All the IP addresses were changing. Not everyone is having the same, etc. So basically, what happened is that obviously the security groups and the rules were managed by Terraform. It was pretty locked down, actually. But what happened here is that to help go quicker, they opened everything, thinking that they would remember it the next day, because as we said, Terraform was to sit. So if we go to VPC, AWS security group.cf, we have our super secure security group with no rules in it. And we have our security group rule, which again, it's a simple version of the story. It only allows 22 SSH on the local network. So it's pretty locked down. Nothing can get out of it. So let's go to AWS now for the demo. VPC. VPC security group. All right. And so what happened? That's once again a very dumbed down version of what happened in reality. They just allowed anything from anywhere and very creatively named this rule temp and saved. So basically, that should be catched by any scanner, security, policy, enforcing software, etc. But well, unfortunately, this team was too small to have that kind of tools. So what happened is once Terraform apply in the VPC, so basically we have a security group which is open to the world now, and Terraform didn't see it because it's not its job to see things like that. It's as simple as that. So let's go back here. We had another terrible story. It was basically a team building stuff on S3. So there were hundreds of developers building a plugin, and it was for development purposes, and everybody was pushing many times a day, every hour or so, a new version of the plugin. So you can guess it was getting pretty big. And now it was all on the same bucket, so it's simple like that. And basically what happened with this team is that another team decided that they needed versioning on all the other buckets, and they were pretty much aware that this specific bucket should not have it. So they did pretty good script to do it, but guess what? It was bugged, and they activated the setting on this bucket, and they were not nobody noticed until they received the bill at the very end of the month. So it was terrible. So once again, let's do this for the sake of the demo, and then I'm going to show okay, that's the bucket. So I do it manually, but it was directly on the API. So we enabled versioning, and now let's go back to the terminal. S3, Terraform, apply. Yeah, a single word. It's not supposed to work. And yeah, unfortunately, Terraform does not see that a manual change happened in this case as well, because for many, many different kind of reasons, it's written on the state directly, etc. So that's about all the things that it's to illustrate the kind of drift you can have in real life. Not everyone is heavily tooled. There is a lot of solution in the field to work around in security, in testing. I think TerraTest is a pretty wonderful framework for testing. Inspect, it's written in Ruby for the oldest of us. I really like it. We have a lot of analysis tools like Checkov, TF-Link, TF-Sec. I showed them all a few months ago here. They are really, really cool, and they will detect a lot of things. Obviously, all the policy and compliance tools. We have OPA, Open Policy Agent. We have Sentinel. We have many, many tools like that. Some are easy to use. Some are less easy to use. Some are using the state file, the code, the intention, the reality, etc. But not many tools are triangulating reality and state in the case of Terraform in our case, and that's basically the reason why we needed a very simple tool, open source, to very quickly, without having to define policies, etc. That's why we created drift control, driftctl. So let's go now to the quick demo for drift control. So now you remember all the changes we made manually. So basically, if you're new to Terraform, you have a state that reflects the reality of what has been applied online on your AWS account. So basically, drift control scans for the real resources on your AWS account and compares them to the state. So if you have many states because you split the VPCs, the S3 buckets, etc., or environments, applications, I don't know. So you add multiple states directly, you scan, And now, now we're going to show what drift control can see and how it can help very easily without any prior knowledge, So what we see is that we have unmanaged resources now. So drift control handles three kinds of status: unmanaged, deleted, and changed with the diff displayed on the tool. So we see here that we have our two security groups that were changed with the rules that allowed everything from anywhere, anytime. So that's, we see it. We have the administrative access policy added to the intern, so we can see it. We have the key that was manually created. We also added some nice data, like the number of resources covered, the coverage in percentage, and some data extracted from that. So that's without any prior knowledge of what you want to check, without any, it's not about PCI DSS, it's about knowing what changed on your account when you are not in the case of a totally locked down environment. And even if you are, then you can get reports and be sure that it's still locked down. So I missed my slide. So, okay. Drift control, it's written in Go. It's been very recently released. It's been released just last month. It's pretty hot right now on GitHub. It's cool. It's licensed using Apache 2. We support AWS right now. More is to come. GCP, Azure. Go vote on Discord. We have a community Discord. Please come and talk to us. We are eager to listen to your feedback and how you do things. So yeah, we want to support GCP, Azure, but also providers like GitHub, etc., plus Pulumi and all the other solutions right now in the infrastructure as code universe. Terraform states right now are supported locally and on S3. We have many filtering and ignore support, because we are pretty much aware that you have huge AWS accounts, so you can filter using tags. You can using only some kind of resources on the S3 bucket, etc. So you can have pretty much anything integrated for you quite easily in your CI systems or in cron tabs or on your laptops even. So that's about it. Drift control, it's on GitHub. We are on Discord, and I would really like to meet you all on the chat and on Rumbly in a few minutes. So thank you for attending, and see you on Rumbly. Thank you. Bye-bye.
Awesome. Thank you so much, Stephane. That was fantastic. We have about 5 minutes, so I'm going to pull up a little bit of live poll again, just to see if there's any questions from the audience. So you can go to this link, pollev.com/CherylHung278. And then if you have any questions, then you can please just type them in so we can see them. And you can also like upvote and downvote Reddit style. So let's just take a minute and see if there are any questions that come in.
Everybody went downloading drift control to scan their AWS accounts.
That would be pretty sweet.
Yeah.
It is actually a pretty cool tool. As I said, when we were doing the survey earlier, the question earlier, I didn't realize it was such a big problem.
Yeah. Well, not so long ago, we were not almost able to properly automate our infrastructure. So right now, yeah, we have pretty awesome tools like Terraform, but it's now we have new problems. So it's cool. We can fix them.
I mean, this is kind of the fun thing about being in this space. Things are moving pretty quickly.
Yeah. And the cool thing also recently, so once again, we released publicly like 4 weeks ago, and we already have many contributions from all around the world. We had people from Greece, from the US, from Japan, major contributions from Japan as well. So that's quite cool. Like we are solving an issue people have, and it's cool.
That is super cool. It's so nice that people can just contribute from wherever they are and they find it useful. They can use it and just download it and contribute back.
Indeed.
Okay, feels like we're probably not going to get any questions. So
All right, cool.
I'm going to turn this off. Again, if people have questions, Stephane, what is the best way to get hold of you?
Well, on Twitter, but more, it's even better if people can go on Discord. So you can go directly on GitHub and read the README, click on the button to join the Discord, and where the full team is coding all day long on Discord. So we even live code using the video broadcast. So yeah, come join us on Discord.
Amazing. Thank you so much for presenting, Stephane. Really appreciate it.
Thank you. Bye-bye.
For everyone else, we're now going to take a 15-minute break, and then we'll come back to our third speaker, Robert. So I'm going to once again share my screen, and you can just listen to some music. Feel free to just chill out, grab a drink, get up, stretch your legs. We'll be back in 15 minutes. Hi folks, we are back on now. So I'm going to hand over to our third speaker. Robert, are you ready to take over?
Yes, I'll just move my rambly dog a bit farther away here so that I don't hear everyone chat. All right, I'll be by the butterfly. Okay, I'm ready and I'll share my screen. And you should be able to see the presentation, hopefully. So let's go. I'm going to talk about LINSTOR, and the whole thing around it and everything it does is also known as LINBIT SDS. So LINBIT is the company that I work for and that I have been working for since 2013 as a software developer. I'm the principal architect of LINSTOR. And the whole project started in late 2016. So it's pretty new. I think we started using it in production in 2018 already, kind of beginning of 2018. And with a couple of testing customers, more or less. And what it is, as the name implies, LINBIT SDS, it's software-defined storage. It is not specifically for cloud applications. You can run it with just about anything, obviously also cloud platforms. So our focus will be mostly on that today. Short introduction to LINBIT. We're a company based in Austria. That's where I'm talking from to you now. I'm in Vienna. That's also where our headquarters is. And we have a branch office in Oregon, on the west coast of the United States in Portland. We have a partner in Japan, and we have various partners or partner companies that also help us service our product and do sales and things like that for us all around the world. LINBIT has been around since 2000, and the most important product was DRBD because the whole company was more or less built around DRBD, and DRBD does data replication. We'll hear a bit more about that shortly. So I'll start off with what LINSTOR builds on. So we'll take a look at what the base technologies are, because LINSTOR itself is open source, DRBD is open source, and we build on open source technologies on top of Linux to provide a software-defined storage system. So I'll tell you about the base technologies that we use and how LINSTOR integrates all of those and how it connects to platforms like virtualization platforms and container platforms. So one of our most central components, you probably know about that one, is Linux LVM, the logical volume manager, where you just have a bunch of physical volumes that you throw into a volume group, and then you can pull out logical volumes. You can create those, delete them, resize them, rename them, whatever you want. And any one of those could be larger or smaller than any of your physical volumes. I think the basic idea is pretty well known. It also enables you to do the same thing with thin provisioning. So you could have volumes that are virtually larger than all of your physical storage. Obviously, you can't write that much data to it because you don't actually have the storage, but you don't really have to resize when it grows. You just put in more physical disks, increase the thin pulls, and your file systems on your virtual machines, for example, already think they're terabytes big, even though you don't have the storage. And another thing that this technology enables is also efficient snapshots, because without thin provisioning, you can do snapshots, but it does it by more or less copying data. So it gets rather slow if you have lots of snapshots of the same volume. And with thin provisioning, it's a copy on write mechanism that we use. So below LINSTOR, most of the time you'll have either LVM or CFS, and CFS is not normally part of the Linux kernel, while LVM is, but CFS is available in certain distributions like Ubuntu. So some of the functionality that LINSTOR provides is provided by LVM, for example, snapshots. That all takes place below DRBD. We also integrate support for certain layers that you can put in between the backend storage and DRBD, like caching, deduplication, and encryption. And I'll go over these really quick because we don't have that much time, and I'd rather like to show you the system in action than show you lots of slides with lots of text on it. But that exists. So you can do deduplication, you can do encryption with LINSTOR, and all of that also builds on the base technologies that are already present in Linux. So VDO, for example, there we have CFS as an alternative to LVM, which also can provide RAID system, and it has its own caching layer, so you can use that instead of the BM cache. And obviously also thin provisioning. And then the other large part that's important and that LINSTOR was originally built around is DRBD. And that's also one of our products, our main product more or less. And that replicates data between nodes. Back in the old days, it used to be DRBD up to version 8. That used to be 2-node clusters. So you had one cluster node where your applications were running on a certain DRBD resource, and then you had another node and it would replicate to the other node, more or less like a RAID 1 but over network. And with DRBD 9, starting with DRBD 9, the most important change was that you could replicate to up to 32 nodes. So you could build 32 node clusters, and you could have triple redundancy, quadruple redundancy, 6 times, 8 times, 10 times, as much as you want. Typically, you would have either dual redundancy or triple redundancy. If you have multiple data centers, maybe triple redundancy twice, so you have 6 copies of the data. And you can also put in clients that do not actually replicate the data, but they do have access to the data, kind of like iSCSI, more or less. So if you think of it as an iSCSI system, and it's very similar to that, then it would look something like that, where you have a target with storage, obviously, and IO requests from an initiator to the target, and data answers and completion answers to the initiator. But then you would also have something like a RAID 1 between your iSCSI and local storage. And that's not actually how DRBD works, but that's very similar. So that's a kind of comparison, we could say. So what it actually does is it has local storage in both nodes. In this case, I'm showing you a 2-node cluster. Obviously, you can do the same thing with 3 nodes, 4 nodes, 5 nodes, up to 32. And for each resource, you always have a primary. The primary is the one where you have access to that resource and where your application is running on top. And you can move this primary around. So you can stop the primary mode on one node and you can go to another node and activate it there. And you always have the same data on all of those nodes. There is a TCP/IP replication link for each resource. You can also have multiple resources. So each resource can be active on a different node. That's how you can build active-active setups. And all the replication just takes place over TCP/IP links. There's one link per resource. You can have multiple volumes per resource, and there are some interesting differences between having multiple resources and multiple volumes per resource. And that's why we call it a consistency group. If you have multiple volumes in one resource, either all of those volumes replicate or none of them replicate. And they also all go through a single replication link. And they're also all active on the same node. So you cannot have one volume primary on one node and another one primary on another node if they're in the same resource. But you could do that with different resources. So that's the major difference here. That's useful if you have applications, for example, like a database where you have the actual data and the database logs on different volumes, but you always want to have them consistent. So if the data for some reason stops replicating because your other data center is down or something like that, then you would also like the logs to stop at exactly the same point in time, so that at the backup site, you basically have an old state, but a consistent state where the database logs are at the same point in time as your actual database data. That's what you use those consistency groups for. You can synchronize synchronously or asynchronously. And the difference here obviously is with latency. So if you do long distance replication, that does not have to be exactly at the same point in time, but you're using it more like something for disaster recovery or to take backups and snapshots and things like that. Then you can do asynchronous replication over long distances without a performance impact latency-wise on your actual high availability systems. That was the idea behind that. And with synchronous replication, you have to guarantee that once you write to the primary and the Linux kernel comes back to your application saying that your write request is finished, all of the nodes that replicate will have finished that write request, and you have exactly the same data and are at the exact same point in time on all of your nodes. Diskless nodes are the thing that I mentioned briefly previously. So where you do not have any local storage, but you can still access volumes on other nodes. So you have dbd installed on some system that does not actually replicate, but it will contact your storage nodes, and those are simply secondaries. And all the data that it doesn't have locally, it will just read and write to those nodes. So kind of like iSCSI, as I said. And dbd also handles a failed disk like that. So if you have a system that actually has local storage, but one of the disks fails and the local storage is unusable, it still works as long as it has up-to-date data on any of the nodes in the network. So if there's another node that has a copy, a replica of all that data, then you don't really notice locally that the disk is gone. It just works like a dbd client. And you do not even have to stop applications to repair that. So you can just plug in a new disk and it will resync in the background and your application still keeps running. Just works as if there were local data. Then dbd itself, that's a Linux kernel module. It's under GPL, obviously. dbd version 8 is even upstream in the Linux kernel. dbd version 9, we are planning to get that upstreamed. It's not yet upstreamed. And you will have to either get the source code of dbd 9 and build it yourself. You can get it as just like dbd 8 GPL open source software, GPL version 2. And otherwise, you can obviously purchase binaries from LINBIT, including support and all those bells and whistles. And for LINSTOR, you need to use dbd 9. It does not work with dbd version 8 because building only 2-node clusters with LINSTOR would not make too much sense. So what it does is it keeps track of what version of data each node has, and it does that by using a bitmap. That's a metadata section. So dbd uses some metadata additionally to your actual data, and that's about the 32,000th in size of your actual data. It's not a lot, so it's just a small overhead. And resyncs are normally partial resyncs. It does not have to copy all the data over if something fails in the meantime, like if it disconnects or if you briefly pull out a disk and put it in again and the data is still on it, then it can just resync partially. You can do full resynchronization if you want to. You can also do checksum-based resynchronization if something happened to your backend storage and you just need to make sure that all the blocks are the same, but you don't want to spend all the bandwidth on resynchronization, and it will just check checksums on both nodes, and if they do not match, then it will resync. So there are lots of features like that in dbd. It also integrates with fencing if you have a cluster around it, like pacemaker and coresync. It has its own quorum logic, and you can have lots of resources and volumes. So the absolute limit per node of volumes is about 1 million due to limits of Linux itself. You can't have more minor numbers per driver, so that's where it tops out. And resources wise, there is not really a hard limit. It's more a limit regarding memory and practical limits like performance of just managing that many resources. But we have used it in production with about 2,400 resources on our systems. And you could have a lot more if you have the capacity for that. There's also a dual primary mode where you can write on 2 nodes at the same time, but it's very limited at this point in anything else than a 2-node cluster. And it basically just works for live migration of VMs. That's what we use it for temporarily. So it will be enabled, but it will not actually be used all of the time. It's only used during live migration. And let's not talk too much about the details of DAVD. There are certain performance optimizations. You can read up on those on our homepage, but I would rather tell a bit more about LINSTOR itself. And finally, there also is WinDAVD. That's DAVD for Windows. It started as an April Fool's Day joke long ago, and then finally there was actually demand for it, and now it exists. So just as a side note, that is a thing. And now LINSTOR, what does LINSTOR do? It uses all those parts, LVM, CFS, deduplication layers, encryption layers, snapshot capability of LVM or CFS, caching, all those things, even NVMe and providers for that, to build a storage system that can replicate the multiple nodes using DAVD. That's what it does and what it's meant for. You can also use it without DAVD, just for local storage or just for connecting a single NVMe device to an NVMe receiver somewhere else. But the intention originally was to allow you to build storage clusters that replicate storage using DAVD. So that's the main use case for LINSTOR. You can build storage from just generic x86 nodes, AMD64 nowadays, obviously. It does not have to be x86. It's also supported on pretty much all platforms that can run Linux and a Java virtual machine, because LINSTOR is implemented in Java. The rest is just in the Linux kernel and Linux user land, so anything that runs Linux should be able to run DAVD and all the other Linux technologies. And if it can run a Java virtual machine, at least version 8, then it can also run LINSTOR. And we currently have binaries pre-built for our customers on obviously x86, AMD64, and also on Power, on ARM64, and on C architecture, IBM mainframes. Then the systems that we can plug LINSTOR into obviously includes Kubernetes and Docker, but also virtualization platforms like OpenStack, OpenNebula, also smaller ones like Proxmox. So there's a full list on our homepage what we support. And LINSTOR itself is pretty much agnostic to what kind of technology it provides storage for. So there are connectors, and you can even write your own connectors using the LINSTOR APIs to talk to LINSTOR and get storage for whatever platform you want to plug it into. And finally, the most important part on that slide, it's also open source. It's on the GPL version 3. So that's a difference with regards to DAVD. DAVD is GPL version 2, LINSTOR is GPL version 3. So what can you do with LINSTOR? If you have storage nodes, so not hyperconverged setups, then you will just have storage replicated between the storage nodes using DAVD and the client on your, for example, hypervisors. It might also be container platforms instead of a hypervisor. And if you move a virtual machine to another hypervisor or container platform node, then we just move the DABD client there and you have access to your storage nodes. Pretty simple. If one of the storage nodes fails, that's completely transparent, because as long as there is at least one storage node available, you can still access all the data. And the other ones will resync once they're back in the cluster. The more typical setup with container platforms is hyperconverged, where you have local storage and your hypervisors or container nodes are also storage nodes. And it's pretty similar there, except you have local storage. And if you move a virtual machine or a container workload to a different node, then you can move it immediately and just have a DABD client and access the data remotely. But if you think that that's bad for performance due to all the network traffic, then, and in that case, I have to say read traffic, because you will always have write traffic if you're replicating. But if you don't want to have the read latency, you can move a volume underneath the existing workload and just resync. And when the resync is done, you'll have local data and it will be read locally instead of remotely. And then obviously you've increased your redundancy by adding another replica. So you can just drop an existing one and go back to the level of redundancy that you had before. The architecture is LINSTOR consists of 3 main components, 2 server components. There is a controller and there's a satellite. The controller keeps all the data. And the satellite is pretty much stateless, receives all the configuration from the controller. There has to be at least one controller. You can have multiple standby backup controllers for high availability reasons. And there's a satellite on every storage node. And the third component is anything that connects to it, typically a LINSTOR client or some kind of connector that connects it to OpenStack, OpenNebula, Kubernetes, Proxmox, whichever platform you want. And you can use multiple connectors at once. You could have one LINSTOR installation that serves different kinds of platforms, like a virtualization platform and Kubernetes platform. And it can also work with the client concurrently on LINSTOR. So it's pretty open regarding that. There are constraints on data placement. So it can auto-place resources in your cluster. You just tell it to place a resource with triple redundancy somewhere, and it will automatically figure out the nodes where you have enough storage available to do that. That should be pretty simple. It's also pretty open. You can invent your own tags and key values, more or less, and they will be compared according to your rules. So you can say, I want to have the same value on this key and different values on that key, and that will be your constraints for placement. You can have multiple network paths that can be used for DABD multipathing, either for failover, or there's a commercial add-on for load balancing if you have the RDMA transport. And finally, a bit larger list of our connectors. So Xen is also one of the supported platforms. We have a CSI plugin. We used to have a Flex Volume plugin. It works with Docker Swarm and Mesos. There are a couple of others that you can also use LINSTOR with. There's also a case study that we're doing with Intel, and I'm not sure whether you can find a lot about it, a lot of the details online, but there is a system that's called the Intel Rack Scale design. And that is pretty much a scalable large storage system optimized for performance. And internally, that system works with LINSTOR and DABD. Or actually, I'm not sure about the DABD part. It used to work. I think the prototype did, and the final system didn't. It works with NVMe remotely, but LINSTOR is still in it. So you might want to look that one up. And then I'll switch to terminals, so the thank yous for later, and show you what it actually is about. And I'll just use it manually here, because if you just click on things in some kind of platform, you know what that looks like. But let's see what LINSTOR actually looks like if you use it manually and what all the components are that it has. So we have a 4-node cluster. All of them are online. Combined is a controller with a satellite. And we have nothing defined on it. There are no resource definitions here, and also no resource groups. And a resource group is a profile that you can set for integration into whatever platform you are using it with. And that's what I'm planning to do. So I will create a resource group where we tell the system what we want it to do whenever it gets a request from, for example, a Kubernetes platform to create storage for it. So I'll create a resource group that I just named triple. It doesn't really matter what the name is. You choose the name. I want thin provisioning, and that's just the storage pool that I have configured. We don't have that much time, so I have to skip a lot of things here. But I think it will be pretty clear what it does once we get this done. And our layer list is DRBD and storage. So we will have data replication placed directly on top of, in this case, an LVM thin pool. And in layer list, that's where I could add other things like encryption or something like that. I think the name is actually just crypto. So in this case, simple setup, just data replication on top of storage directly. And let's see whether I typed everything correctly. So it tells me I have a new resource group, and I should be able to see that in the resource group list. So I have a replica count of 3. Every time I use this profile for creating resources, I will get 3 replicas, triple redundancy. I will get it thin provisioned, and I will get DRBD replication directly on top of storage. That's the kind of profile that we get. And another thing that I need to tell it is that I want 1 volume in this resource. So I just do volume group create on my resource triple, just a single volume. And let's look at the resource group list again. I basically just source the volume number, volume 0. And then I can just spawn resources off of this definition. So I do spawn resources from the resource group or profile, if that's what you want to call it, triple. And my resource name is going to be magic. And that volume is just going to be 100 megabytes volume. Let's see what that does. And what I have on the right side here is a monitor that shows you what DRBD is currently doing. And I should probably show you what that means, what you can see here. So the resource is named magic. It's currently secondary. It's replicating to 2 other nodes. We're on node Romulus. It's replicating to Kronos and to Remus. Those are the nodes that LINSTOR automatically chose for provisioning this resource. We have 1 volume that has backend storage. It's teal marked. Volume number 0 with minor number 1000 on this system. And since we're on Romulus here, we should be able to just write a file system to it. And I could even include that into the resource group in LINSTOR and tell LINSTOR to automatically create file systems on top of it, but I didn't do that, so I'll just do it manually. And there will be a device that is called DRBD 1000. It just numbers those resources, and depending on your UDEF rules, you can also have them named DRBD underline magic, and it'll point to DRBD 1000. And then I have a file system on top of that, and I can immediately just mount that def DRBD 1000 to MNT and touch a hello LINSTOR file on it. Here it is. And then just to show you that replication actually works, let's do that same thing here and go mount def DRBD 1000 to MNT on this node. and here's our file. So that's pretty much it. It's as simple as that. I think time-wise, we are, I think, pretty much done.
Yeah, we just hit 9 o'clock, so
that was just on time.
But yeah, thank you so much, Robert. Really appreciate you sharing your experience and Linda with our group today. What's the best way? We're out of time for questions, but what is the best way for people to get in touch with you?
There is a Slack community for LINBIT and DRBD and LINSTOR, and there's a DRBD and the LINSTOR channel on it. And we have mailing lists at lists.linbit.com. You can also find them on our homepage at linbit.com. And personally, obviously also on GitHub. LINBIT is on GitHub. I am on GitHub under Altnoeder, just my initial of the first name and my family name or last name. So you can find me on all those platforms.
Fantastic. Thank you so much again.
Thanks for watching, and thanks for the opportunity to present here. And yeah, we'll see each other, I think, on Rambly.
Yes, exactly. So if I can ask you to
more.
Stop sharing your screen for 1 second.
And I'll stop my share.
Yeah, so thank you so much, Robert, and thank you to all of our speakers and sponsors for tonight's Cloud Native London. We're going to be back again on the first Wednesday of March, where we'll have another 3 speakers and we'll hang out and chat. I'm going to go over to Rambly, so go to oicheryl.com/r if you want to come and chat and hang out with us for a little bit longer. Otherwise, thank you so much, and we'll see you again next month.